Hello, in this video you will learn about one of the properties of exponents known as the power rule. So in this case you have either a number or a variable with an exponent, then this is inside a parentheses and there's another exponent outside the parentheses. So you have something with the power to a power. That's why it's known as the power rule. And if you look at the rule, all we have to do is multiply the exponent on the outside times the exponent on the inside, and that would give us our answer. Let's try it out with problem number 1. So in problem number 1, we have 3 on the inside, 2 on the outside. Using the power rule, we multiply 3 times 2. So x 3 times 2, this gives us x to the 6. If you didn't use the power rule, this means that you have 2 of whatever's in here. That would mean x cubed times x cubed. So it would be x times x in one parenthesis, and there are 2 of those, x times x times x. That would give you also x to the 6, because we have 6 x's being multiplied times each other. This is just a lot more work, so we will focus on using the power rule. Similarly, on the next example, I will be multiplying the exponents. This works with numbers as well, 2, and the exponent is 5 times 2. That would give us 2 to the 10. Now, if you wanted to simplify further, you would have to evaluate 2 to the 10 power in a calculator, and that would give you the more exact solution. For now, I will leave it at 2 to the 10. Problem number 3. Sometimes we have that this exponent applies to a negative number. So that's why we have more than one set of parentheses. The rule is still the same. We put negative 4 inside a parentheses. We multiply the exponents. 3 times 2. 3 times 2 would give us negative 4 to the 6th power. Sometimes we might also encounter something with negative exponents, which we would treat the exact same way. We have y. Now we multiply the exponents. Negative 2 times 4 is negative 8. I will show you how to simplify negative exponents in other videos. So look for the video with negative exponents. We also have the power of product rule. This is a variation of the power rule, so it's slightly more elaborate. We have now 2 different variables inside, each one with its own exponent, and we have a power on the outside. So in the inside we have the product, and outside we have the power. In this case, basically what we do is we distribute the exponent. Let's start with number 1. We have m. We will distribute the exponents. 3 times 3, 9. Then we will do for n. 3 times 2, 6. So each one of the exponents on the inside gets multiplied times the exponent on the outside, which in this case is 3. Similarly on the next one. Now, the 3 does not have an exponent, so I'll be putting a 1. And we multiply the 4. 4 times 1 on the 3 gives me 4. Next one is 4 times the 3 on the 5. That would be 12. And last but not least, 4 times negative 2, I'm multiplying the exponents on the x, would be negative 8. For now, I'm only showing you the power of product rule, but you could simplify this problem further. What if we have a fraction? We multiply the same way. We have 2, and now we multiply the exponents. The exponents would be 5 times 2 over 3. I like multiplying fractions. I will convert this one into a fraction. Multiply the top 2 numbers. 5 times 2, 10. The bottom 2 numbers, 1 times 3 is 3. So this would have 2 with an exponent of 10 thirds. Same with the other ones. It would be y. I multiply the exponents. 6 over 1 times 2 over 3. This is 12 over 3, and that would give us 4. The last one would simplify to x squared using the same method.